We will have today a presentation by Professor Eisenack from Humboldt-Universität Berlin. He's a very well-known economist in the area of climate economics, energy economics, and resource economics, and he also holds the position for resource economy at the University of Humboldt University. He has several publications in all of the well-known energy-related, climate-related, and environment-related journals. I don't want to go into the details because it will take all the time of our session. But what's also interesting to me, at least, is that he created a small simulation model that's, so to say, kind of a toy, if I have interpreted this correctly, a climate tool, Keep Cool climate game. And I would invite you to enter this game and try it. Maybe we'll get some information from you during the discussion. Today, he will go into a topic that's related to urban economics, another field that he's interested in. And he will look at the trade-off between setting environmental goals at the community level versus the costs in terms of political, maybe also. So please, Klaus, the floor is yours.
Yeah, thank you very much.
Start the presentation.
My connection is.
At least it's not it is red.
Shall I try?
Yeah. It's working.
Yeah, so then thank you very much for the kind invitation to speak to you today. I would like to, as a kind of subtext of the presentation, I would like to say, some of you are eating, I want to give you flavor, and in terms of why it's interesting for economists to study issues related to urban climate action. But in the main part, I will report on a paper that has been accepted some weeks ago with exactly this title here, which gives a theoretical take on the whole topic. And if I find more time, maybe I'll report on another work in progress paper. So actually, I'm happy to be interrupted if some things got unclear. So I'm not sure how far I get when you interrupt me a lot, but it's up to you. And I think you will stop me, right, at some point.
Yes.
To have a discussion. Yeah. Okay. Yeah. Why do understanding cities matters when we think about climate change? And here are just some thoughts. Cities, of course, matter because a lot of carbon dioxide emissions and other greenhouse gas emissions originate in cities. There are different ways to estimate and conceptualize this. So 56% is one of those numbers that is around of 70. So 70% is one of those numbers around. And of course, cities are large. More and more urbanization processes are going on worldwide. So more than half of the world population nowadays lives in cities. Again, setting aside, it's not so straightforward to define what a city actually is, but there are some definitions one can work with. But cities are not only originators of climate change, there are also some indicators that cities might be more vulnerable to the impacts of climate change than other, maybe rural entities. That's again the high concentration of people living there. Cities have many cities are close to the coast, so sea level rise is a matter here. Cities have dense infrastructure, so when infrastructure is interrupted, say by extreme weather events, we might have spillover effects to various sectors that are close together. And another example is this urban heat island effect that global warming manifests in a much stronger way, +7 degrees Celsius in some cities than in the global average. So still one might say, okay, cities matter somehow, but do they also matter in terms of decision making? Maybe they're just originators and victims, yeah. But of course, there are huge differences what city governments can do if you look around the globe. But there are some sectors like spatial planning, waste management, organization of transportation that matter in many cities. So even Chinese cities have a lot of authority how to organize waste management, for example. And of course, for the United States or other federal countries, local governments have much more authority to make decisions on important shares of the emissions. So that is maybe why it makes sense and whether it's possible that cities act on climate change, but can we expect this to happen? And here, simple micro 101 sketch. Yeah, we can say, okay, cities, if they do something to mitigate climate change, so this is jargon for reducing greenhouse gas emissions, they have costs for these reductions, and we might have a marginal cost curve that looks like the red one here. And when they contribute, so then they have more emission when reducing greenhouse gas emissions, they reduce damages from climate change worldwide. But from the perspective of a single city, this marginal damage that is reduced is quite low. It's just one city among hundreds or billions of cities actually on the world. Here with private, I mean the marginal damage from the perspective of a single city. So that's private as maybe is imprecise here. Yeah? But you see with this, we have a global public good situation here. We cannot expect that cities do anything here. Yeah? The optimum is 0. Yeah. So we might think about, okay, and there are studies now that say when we reduce greenhouse gas emissions in cities, we might have considerable co-benefits. We might have the situation that by improving our transport and heating system, we also reduce pollution with particulate matter, local air pollution, and this is to the direct benefit of those cities. So then, with this, we might get to a situation if we subtract those co-benefits from those marginal costs, we might get a dashed red line here. And if we then are in a city that is maybe more vulnerable to climate change than another one, so we have an upward green curve, say if it's a coastal city compared to a quite safe city, then we might say possibly we are in a situation where we can expect that from the perspective of a city, it is rational to undertake some effort here. And we can think about hypothesis, right? The higher the co-benefits, the higher the vulnerability, the more likely it is that we have something positive here. But generally, hey, not very likely. We could tell a similar story about adapting to climate change, but maybe I'll leave this out for today, maybe for discussion later on. But actually, what is happening in the real world compared to the simple prediction here? And this basically falsifies this prediction. So this is a world map of cities which have pledged to reduce emissions down to net zero by 2030. We see many of those cities on all continents. And so these are pledges, right? There are even more cities that have climate plans. So they might make a city level strategy what to do about climate change. There are thousands of those cities. The map would be looking even more populated with dots here. And it's also acknowledged in the international arena. So when you read, for example, the preamble of the Paris Agreement, it acknowledges different things, but also that all levels of government should play a role here. And actually last year, at the COP, so exactly 1 year ago, it was the first time that the city sidetrack was an official part of the negotiations. So this is acknowledged somehow. But if you say, okay, there seems to be something that is at odds with the simple prediction here, we can say, okay, what is actually then driving cities to do something, to propose those plans or those pledges? And there's already some literature, some empirical literature out there, mostly I would say in political science and geography, not so much in econ yet, where we can find some stylized facts or topics. So there are many studies who show that cities which have a higher capacity, and here I mean a mix of different things depending on those papers, so cities which are rich, which are large, which have much power, tend to do more. That's a totally different explanation than on the diagram we had before, right? Then there's a huge literature that delves into so-called transnational municipal networks. So these are networks where cities from different continents join and pretend or actually do something about climate change. We have dozens of those networks now on the world. This is data from the Global Covenant of Mayors on Energy and Climate. This is the largest one worldwide. This was taken, the screenshot last year with already more than 12,000 cities. And here you have a map how they are distributed over the world by size. And the color means how long they are. These cities are members of those networks. You can see Europe was early, but it's now all over the world. So, and some studies show that being a member is conducive to have more climate plans. But there are other studies that show cities that have climate plans are more likely to join those networks. So the direction of causality and maybe endogeny issues are not resolved at all. But there's more on the shopping list. What could explain these matters? It might be politics. That we might have cities where we have green voters that request their local governments to do something. And there are some papers who show that. Or indicates this, but there are also other papers who show no effect like that. And these are mostly studies for Europe or the United States. Then we can go back to this damages you can have from climate change, so that a stronger exposure to impacts might lead to more ambition in terms of climate action. Here again, mixed evidence, no clear answer we have yet. And the number 5 here that I already mentioned, this co-benefit thing, which is quite intuitive, mixed evidence. Of course, it's difficult how to measure co-benefits. One way is to use air quality in those cities as a proxy for these kind of studies. Then that's maybe also an important thing. Why should we think about cities if we have nation states that negotiate about climate change to provide the global public good? So it might be that the ambition of cities might be just a complement to national action. So if national governments propose a law, then cities follow suit. That's, I think, quite plausible. While there is another argument, this is that city level action might be a substitute for national action. That is now, with the US situation, a very important question with the new presidency. But empirical studies so far, I would say the more recent studies lean more towards complements, but there's again mixed evidence. Another version of this is number 7 here. It might be that just cities are forced to do something by national law, by national obligation. And indeed, there are some countries now in the world, like, for example, France or the United Kingdom or India, that request their cities to have climate plans. Here we just counted data from Jana Rekin and others for a representative sample of 885 cities in Europe. 2/3 of those had a mitigation plan by 2016 about. A-type means a relatively good plan and not a weak one, which is just blah, blah. And if you split up the sample in Europe with cities in countries with or without obligations to have a plan, we see a difference, yeah. But they would say, now, in particular, British cities are quite good at not following what they should do by their governmental policies. So we have a large shopping list. We have mixed evidence. And maybe that is one working hypothesis that we will unpack a little bit more later on, is maybe it's not a single one factor. Maybe there are non-linear, maybe interacting factors that might hinder or make it more likely that the local government is providing a global public good. We did some years ago a study where we just looked on which European cities of these 885 have a climate plan in presence. So I'm just speaking about plans here. And we looked with a specific method which factor combinations are systematically associated with having a climate plan. And there we actually got 4 different types of cities. And here you see the European distribution. So there are these networker cities that are part of this global compact of mayors and do something. There are green and lighthouse cities. So these are rich cities, sometimes capitals based in countries which are very proactive. But we have also these fundraising trailblazing cities. These are cities that are where we could show that they are mostly driven by, okay, the Polish are particularly strong here. So Poland is not known for being, at this time at least, and are still to be very proactive on climate action, but they more or less weakly force their cities to write climate plans to get access to European Union funds. A completely different type of mechanism, yeah? Okay, so here we see different combinations, but still here I'm speaking about plans and pledges. And actually, what is the value of a plan if carbon dioxide emissions are not reduced? There are some studies out there that indicate, so maybe I don't speak about this part, but this is a study of a team of AI specialists and remote sensors that estimated greenhouse gas emissions on the grid cell level for Europe. And in this paper, they also compared this against the national trends, how emissions were reduced nationally. And they could find that in some areas of Europe, indeed, cities catch up with their plans and sometimes achieve more than the national averages do. Yeah, so there are some indications, but these are young papers. The data is strongly improving now, but I would say measuring carbon dioxide emissions of a single city is still a tricky thing. Yeah. But it might be worth to check out whether this converts into, whether plans convert into action. And this is then part of the paper I want to focus on, and this paper works with a theoretical model because that it's difficult to measure emissions. So now in a good way for cities, so maybe think ahead what we could measure in some, I don't know, days, years, months, and start theorizing about this. So this theoretical model is also made to get to some of these points 1 to 7, right? To address some of those possible explanations, to check out what we can say about them. We can't address all of them in one model, but it does some bits here. What I plugged in here in this model is a public choice angle. So because with a simple rational choice situation, when we assume a welfare or a local government which maximizes local welfare, we can't expect to see much. So here I assume that we have a self-interested local government that might pursue other agendas than just minimizing the sum of economic costs and benefits. Another one, and this relates to the question about are targets and plans really put into practice, that this model distinguishes between the target and the actually achieved emission reduction. The model will then admit a mismatch between those two. And then the question is, right, how close they are to come to each other. See, I was actually surprised. So I did not find much economics literature about the mismatch of targets and their achievement. Although we see this all in practice, that policy targets are not achieved. Yeah, and then I want to, with this actually, with the theoretical model you see on the next slide, I want to then explain under which conditions do cities set a climate target at all? If so, at which level? And then, of course, whether this is can be expected to be achieved. This might be difficult to observe today, right? But whether cities have a target and what is their level, that is things we can very well observe nowadays. And so with this model, I aim to determine some comparative statics profile, and some of them might be then maybe used as an entry point to develop testable hypotheses that can be already checked against the data that is available now. So how does it work? The model takes an objective of the local government, W. So it sets the local government sets, if it decides to set a target, it decides about the level of T and about actual mitigation, M. It is assumed that target setting is happening in the first period, say today, while mitigation then happens in the future. In period 1, we have the economic benefits of mitigation. So these are these low benefits of reducing climate damages, possibly more if co-benefits are part of that. And we assume, in addition to that, to this economic value, to the city, there's also a political value to the local government. So depending on what voters or the local industry want, they might get some political benefit if they are particularly green or particularly brown. So I come to that later. But having a target is not for free. You need to have a discussion process in the city. You need to write documents. So there are transaction costs or costs in the present. That is a capitality. And then the plans are made, if they are made. And then we have the future period 2. And then we have the costs, the economic costs from reducing emissions to a certain level. And we have political costs that say something, okay, if the local government is not reaching the promises, the own promises, there might be, say, a political punishment of that. Maybe the future lobbyists or renters or voters might say, hey man, they did not hold up to their promises. If we have a government that is ignoring about this, then this S function would be 0. So that is a special case. And this is why these various parameters are in there. So we have this delta, which measures the private cost of carbon, so how vulnerable the city is,
Why do you need the function S if you have already the function V? So couldn't be V negative if the cost is higher than the political value gained by reaching the target?
B can't in principle be negative. Here we need to make monotonicity assumption, but the point is that S contains M and T. So it's S depends on how the mitigation and the target are related, whether you mitigate more than promised or less than promised or exactly as promised. While B is independent from your target. Yeah.
But V is the political value of target.
You mean we? Okay. Yeah.
So I don't see why you need both terms, to be honest. Still not.
Now you can say if voters or the local constituency can anticipate in how far mitigation will be conducted in period 2, then you might have S and V be composed into one function. But the picture I have in mind here, you have a local government who proposes maybe a climate plan because it's opportunistic, and then some years pass by and the plans are put into practice, and maybe we even have a change in the local government. And then the question is, does a future government, when the actions are put into place, respect their past targets or not at all or a little bit? And this is captured in the function S.
I have a pretty related question. I have a different problem with V and S. I think that T cannot be the same. You cannot set the target and have the cost of not meeting the target at the same time.
Yeah, but it's 2 different periods.
Yeah. So T is, say Vienna says we want to, I don't know what the actual target is. Vienna says we want to reduce carbon dioxide emissions by, I don't know, 20% until 2025. And then maybe that has happened last year. And then the next year, 25 unfolds. And then say the local government in Vienna can say we make more ambitious programs to get our emissions down, or we can say, oh, we don't care about what we had promised 2 years ago.
So the costs are known at the time T.
Yeah, in the simple setting, there's no uncertainty here. So in principle, you can anticipate what is happening if you know how the function S looks like. But in principle, you can gain something on the short term by making promises, and you can lose something in the future if you don't meet those promises. When you say promises and what you reach is always the same in a one-to-one relationship, then we don't need to have an M and a T. Then we have just the M in there, or maybe just a T in there, and we can get over. But then we assume that all governments always hold up to their promises. And this is an assumption I want to get rid of here, no? No, does it erase your point? Or? Yeah. And we can think about different mechanisms, right? We can think about, say, maybe there are local elections now, yeah, and there's a very green constituency, so maybe the local government is making a high promise to decarbonize, to attract those green voters. So this is then a value in the present. And then the election has happened, and I don't know, maybe then the Green Party has won or not won. And then the future government, or maybe the same party in the future government, might exert influence to be more or less ambitious. And here I speak about we being something about green voters. It can also mean that you have a very brown constituency. So this is actually this parameter psi. This parameter psi is a so-called bliss point. It's a U-shaped function we have here, and psi is the target that your electorate likes most, you might say. So if you have a very green city, psi would be a very large value, but there might be other cities, maybe where you have where you have a lot of fossil fuel-based industry, then psi might be a very low value. Here I'm vague whether I speak about a public choice model involving about elections or lobbyism. So actually it's a reduced form here. We just assume we to be convex and U-shaped. And whether this is explained by a lobbyism story or an election story, it's open. So the model can be adjusted to both these kind of stories.
Are costs linear or increasing returns?
So, okay, I did not spot this all. So the benefits are assumed to be linear because the city is small. It just scales with S, which is the size of the city. If you have a double large city, then you might have double the damage. The political value is single peaked with a bliss point. It's convex. The transaction costs are non-decreasing. The mitigation costs are convexly increasing, which is a very common assumption, and they scale with size as well, with S. And the political costs are also assumed to be U-shaped, and they are the lowest when M and T is equal. So you are less punished if you keep your promises, but they all scale with sigma. So you can put sigma to 0, then you would picture a future government which is ignorant about the targets that has been set before. Yeah. So these are the extreme cases, and I think I'm through all assumptions here. Yeah. Okay. So, okay, and with these assumptions, you can get through these different stages. So, is the target set at all? How large is the target? How much is achieved? And here I will go by backward induction. So these are a summary of the finding in a situation where the government has decided to set a target. So suppose this has been decided in this way, then we get some first order conditions and get through the comparative statics. What we can show here, for example, if the city chooses a more ambitious target, it also mitigates more, not just in one-to-one. Yeah, so it's just the same direction, but the slope is different. We can see when mitigation costs are larger, the scales with this kappa parameter. So if mitigation is more costly, then cities choose less ambitious targets and less mitigation. I think this is quite intuitive. While with scale, with size of cities, we get ambiguous results. So we have a parameter W here, which expresses whether marginal costs or benefits increase more with size. And depending on this value, larger cities promise more ambitious targets or less ambitious targets. When we go, for example, for the sigma parameter that expresses how strongly you are punished if you don't meet your target in the future, we get ambiguous results. So here it depends on a very complex expression here, whether when you are more punished in the future, whether you are then more or less likely to raise your ambition. Another one we find when we go back from the marginals to the levels is that actually, except for a boundary case, this setup only admits two types of cities. There are cities which mitigate more than they have promised. We call it here understatement cities. And we have then logically the opposite case, cities which mitigate less than they have promised. But we can show already here that those contributor cities, and you will see on the next slide why they are called like this, actually they mitigate less than promise, and they promise less than their constituency wants. You remember P is the preferences of the local electorate, and they promise less than they want and achieve even less. So why are they called now contributor cities? And we get to that when we go to the earlier stages of the game. Because here we did not find out, does a city choose a target at all? This is just under the premise that they have opted to have some target. But would a city do so? And here we need to compare the situation with a target to one that is without a target. And here we simply assume that if the city opts to have not a target at all, it would just behave according to the standard theory, equalizing marginal benefit with marginal costs. So then we have a certain, presumably very low mitigation level, and the target is non-existent. And then we can compare the welfare, or actually more the objective of the local governments between the setting with the optimal target, the left side, or M circle being the non-target setting city. And this delta then tells us, okay, if delta is positive, it would be better for the local government to opt for the target way, and otherwise it would opt against. Now we can go through under which conditions this is the case. Then we get more on these understatement and contributor cities. So we actually find that those understatement cities that achieve more than they promise, which sounds good, first of all, actually those cities mitigate less than a city without any targets would do. So M circle would be, you might say, the free riding cities which ignores the climate problem except from the own physical perspective. But those understatement cities that overachieve their targets actually do very little. So this is why we choose the term understatement cities. While for those contributor cities that actually fail their targets and promise less than their voters or lobbyists want, actually mitigate more than this free riding city would do. And this is why we call them the contributor cities, because these are the cities that actually contribute more to the global public good than would be expected just by considering the direct economic benefits and costs. And of course, we can go to the comparative statics of the data parameters to see which parameters make it more likely or less likely that a city opts for a target. And some of these are summarized here. So here we have these different comparative statics columns. So this one tells us whether, if a city chooses to have a target, whether this target is higher if delta is larger. So delta can mean this is a more vulnerable city. Delta can also mean, I did not tell so much about this, but because this model is so general, delta can also be interpreted as a national carbon price who is imposed on all actors in the country, so also on the cities. So this is just an addition. You can have either your damages from climate change, and then this here you would have the costs you need to pay, the taxes you need to pay. So we can predict here that if cities set a target, those that are exposed to a higher carbon tax or are more vulnerable also set more ambitious targets. So this is always a plus here. But do they actually set this target? And then we need to go to this column here. And then we see in this table that it matters that we distinguish different cases. Yeah? Here, this W parameter appears again, whether it's a contributor or an understatement cities, and we can also say a little bit more here. But then depending on what kind of cities we are looking at, it might be that more vulnerable cities or cities which with a higher carbon price are sometimes more likely to set a target or less likely. So now we have different types of cities, again, depending on parameters. And of course, we can go through other parameters as well. So we can say there are very different combinations of these pluses and minuses that can appear, but only those. So these are all possibilities that are emitted by the model. They are also associated with an effect on M star, the mitigation level. This is not shown here because it's difficult to observe. But if you find many cities that do not fit into this table, then the model is falsified, even if you can't observe the actual mitigation levels, right? And we can check whether these different cases, how they are defined, really go together with those profiles that are depicted here. Okay, so since I'm running out of time, I won't go into the other paper in progress. I just say it's about explaining when new cities join transnational municipal networks. So in the previous model, cities were considered as solitaires that do their own stuff, and here we get the richer picture, but it's work in progress. So these results are not consolidated. Anyway, it's a subgame perfect national equilibrium now with 4 stages with national governments and local governments that can either cooperate or not. But okay, maybe I spare this here to come to a summary. I hope I was able to show that cities need to play a role and also can play a role in governing climate change in addition to what is going on the national level. I think I've also shown you that although we already know something about factors that might play out here, the gaps are still all over the board. So there's still much to do to resolve this mixed evidence. That is also why, I think we need more empirical research, but also more theoretical research to get around the data availability gaps we have at the moment still. Although there's rapid, there's rapid development in data availability. And here maybe that's also, I know that's maybe in our profession, right? We are happy to get great data, yeah? And I would say a good thing here about studying cities is that we have much more cities and countries on the world. So we have a much larger N if the data is good enough. And this is maybe still where the boundary is at the moment shifting, but it goes into the right direction. So I think there's much we can do. But of course, number crunching is the one thing. Number crunching has already been done before. So I think we also need really to get to the mechanisms that really play out, like in the example that I've shown in this study, where I think also with these specific assumptions from this paper, there are these different cases, cities of type A, B, C, D, that work in a different way. And when you talk to urban geographers and decision makers here, they speak about the enormous idiosyncrasies of cities. Cities are so different. So that is, I think it's quite intuitive. Maybe that's the same explanation does not work all over the board. So you need to be smart enough to tell the right cities apart. Yeah. And I think it's also interesting from the more general economic viewpoint. So much has been written about the private provision of public goods. Here we have a case where we can study the provision of global public goods by local actors, maybe not private ones, maybe local governments or local firms and so on. But I think this is a general kind of question that does not only matter for climate change issues, but also if you're interested in, I don't know, in health, in pandemics, in dealing with crime or other security issues. So we also have a local provision of public goods, more or less under certain conditions. So I think this is it. Thank you very much.
Thank you very much, Klaus. Ina has prepared a short comment, so please go ahead.
So good afternoon, everyone, and thank you, Klaus, for an exciting talk on a theory of subnational climate action. I read your paper with interest because for me it was a rather new perspective. Most of the time I'm dealing with national climate targets. So here I was learning quite a lot about the importance and the relevance, and that's also the focus of my comment. the climate political relevance, but also the economic relevance. Most of the points I wanted to address were already mentioned, actually, but there's still one point I want to add. So cities are centers of high economic activities, and that's why we have this high share of greenhouse gas emissions attributable to cities. So here we have the decoupling of economic activities and greenhouse gas emissions. And that's why also cities are high contributors to global environmental problems such as climate change, but also others. We see that cities drive the land use and land use change via nutrition and food habits. So this is the one side you already mentioned as well. And the other side is that due to this economic activities, cities are already highly vulnerable. They have a high population density. They have a sophisticated infrastructure, businesses, research units. So this is, of course, one of the major interests because cities are interested in climate mitigation. And I just want to mention some of these climate impacts already happening. And if we don't manage to get our climate targets right, then these climate impacts are supposed to impact with higher amplitude and higher frequency. So this is we have like the urban heat island effect that is often mentioned. And of course, we have lots of cities that are situated right at the ocean and that are vulnerable of the rising sea level. Avoiding these adverse impacts is one of the major incentives for cities to mitigate, although they contribute to a global public good. But there's also now another argument that we see from geopolitical frictions and uncertainties. I want to mention, of course, the announcement by the designated presidency of the United States to opt out of the Paris climate target and to allow drilling and mining in nature conservancy areas. So here we need the city action, the subnational climate action to hedge against further aggravation of climate change. So another incentive, that's what you already said, is the local co-benefits for cities in terms of climate mitigation. There are these environmentally related co-benefits, in particular reduced air pollution that arrives from transforming the transport and the heating systems of cities. But there are also the economic, and that's maybe an additional point here, the economic co-benefits, because cities are actually centers of innovation, not only towards environmental technologies, but also towards new lifestyles. For instance, the vegan or the vegetarian lifestyle, of course, originated in cities and not on the land. And these all drives environmentally friendly innovation and also economic value added in this term, so economic growth and jobs. And this is maybe one additional but important point today, given these times of economic recession. And so that is my conclusion. And I think like research of subnational climate mitigation becomes more and more important and relevant for our societies. And this is also addressed in a special report that will be published in May 2027 by the IPCC, the Intergovernmental Panel on Climate Change, on cities and climate change. So I think there's lots of interest in this subject.
Thank you, Ina.
Thank you.
Should I respond? So, of course, there's many aspects here. Cities are not governments, right? Cities are a conglomerate of industrial, social, and governmental functions. And here, maybe it took more as a governmental perspective. There is some literature indeed on innovation in cities. Copenhagen is a case study in this respect. So their climate policy was strongly driven by positioning Copenhagen as an international innovation hub, and then they could foster alliances between many local actors. There are some studies on norm settings, so where industry associations or industries or firms that are spread over different cities use their easier access, sometimes in capital cities, to national governments to establish norms, technical norms that are conducive to their own business. Yeah, so that is another twist we can in. And it's subnational does not only mean local governments; it can also be indeed industry sectors, right? That is, I think, very important. You measured their impacts to climate change and how to react on this. I left this out of this talk, but of course, cities need to respond. Pressure is getting ever higher. And the simple economic logic would say, okay, adapting in your own city, it's a local public good. That's much more easy to provide than a global public good, like greenhouse gas emission reductions. So we would expect that cities are all stepping up for adaptation and not mitigation. The empirical observation is just the opposite. In Europe, in the US, in India, in many countries on the world. So in the sample of 885 cities, there were 2 cities which had an adaptation plan, but not a mitigation plan, 2. And there were, I think, 30-something% cities which had where it was the other way around. Yeah. So really, it's really puzzling. Yeah, from the economic viewpoint. That's an open question to address. Yeah. So these are just some short comments. Yeah.
Thank you. So I want to open the discussion. If you have an intervention, please raise your hand in Teams or in the room. Sergey, please.
Yeah, I've read the last year's version of the paper, so I have a look at it, and I think it has improved a lot in terms of clarity also. So I think I'm glad the follow-up paper is coming, because I think this is the biggest part which is missing in this paper, is the fact that you don't have any. So you have an isolated setting in which you look at a single city, and then you have several types that emerge of behavior, but you don't have a population of players or some interaction. And this is, I think, the best way to improve upon. So I'm glad game theory is coming, and I think that non-cooperative game theory is the correct context in that, although there is a common good. Then one other thing that crossed my mind is whether there is some room for uncertainty in costs or outcomes. And also, if you can reduce the problem really to a single-dimensional problem, if you discount all the future values. I mean, if you look at your formula, the formulation, and that's why I was a bit unhappy about the same T on both parts of the formula, in part 1 and part 2. Because first of all, you can always discount the future to the present and have a single period decision problem. The reason for having a multi-period decision problem is usually uncertainty, or something that you are not sure about in the second period, and that's why you need to handle it in some sense. Yeah, so uncertainty game theoretical setting, I think it's something that would improve. And yeah, and one general question is, what makes this a model of cities? I mean, it could be applied to countries, groups, basically anything. No? So there's nothing in particular. It's an application of a certain framework for cities, which you actually mentioned on one of the slides, that it can be applied to other target setting decisions in the context of spillovers and common good properties, let's say, but actually spillovers in general. Yeah. So I was thinking, is there an element of the model which makes it a model of cities, or is it really just much more general and applied to a particular case? Thank you.
Well, there are different ways. So
I ask Michael Pineda for the next.
Yeah, well, one minor remark you made that made me wonder about the cost of non meeting the targets. You said that it is using paid and the lowest when the litigation meets the target. And that implies that surpassing the target, overachievement, is equally punished politically than underperformance. Is that so?
No, it's not assumed to be symmetric. That's important. This function is assumed it's U-shaped, but it can be kinked. So it might be that overachievement is more punished than underachievement, or the other way around.
So
in this case, it's general. In this case, it's not. Yeah.
Still has political benefit, but
Yeah.
it's same proportion like underachievement. Okay.
No, it doesn't need to be. It can be a complete different proportion with under or overachievement. It can be any function that is just U-shaped, but with, I don't know, with a steeper slope on one side and a less steep on the other. Yeah.
In that case, I find your result more interesting now, because I was a bit wondering about
Yeah, that is so.
the finding, in particular, the finding that how did you say the understatement cities perform less than the cities that set higher targets.
Yeah.
And this means that by setting low targets, even if they surpass them, they put themselves too little pressure, too little incentives to mitigate further than those that maybe give a lot of political short-term gain for setting high targets. We usually would be very skeptical of that. As an observer, we're always a bit fed up with all these big targets put into the public. But your result would mean that even if these are never meant to really be achieved, you have positive net effect in the sense of putting more pressure over time to
So that's a prediction. We can maybe check that. Yeah. But maybe to the other. So of course the question, the model is quite general, and actually we were happy that these convexity assumptions are so flexible. So in this very reduced form, I would say you can apply this to other entities as well. I think that's for sure. Maybe I don't know whether that's a fault that is more general than sold here as a city model, but it comes more when we start to unpack those political costs and benefits, and that is, I think, part of your suggestion. And I think you're right with this. So we can go into cooperation among cities, or we can stay still in the same entity, but say what does this sanctioning political costs and benefits functions? Why do they actually look like that? We might. And this is basically about having a micro foundation of these functions, and here we can think about having models with, say, in the Grossman-Heldman world, where you have a different weight on producer and consumer surplus. There are electoral accountability models we can use, we can have this in one stage and with multiple stages, and then different discount rates and uncertainty unfolding. And I think then we need to plug in specific features, how we model the city. And for example, how it is exposed to national regulation, because that is a huge difference, right? That cities have some authority, but not as complete authority as national governments usually have. So they are more embedded in these kind of systems, and this needs to be respected when we unpack this further. Another, maybe that's not a deep one, but the size parameter. Of course, we also have countries of different sizes. So in this sense, we can apply the same also to countries. But when we really work with real world cases, we have much more variation in the size of cities than we have variation in the size of countries. So the power laws behind this really have other coefficients. So I think when we talk about cities, it's more reasonable to compare across different sizes. But that is not an objection against the generality of the model. It's just that it's maybe important to include the size and not neglect it, right? I don't know how far this addresses your concerns, but these could be expansions now. Yeah, and another important is right in particular with this political value. If you don't meet the target, how can a current decision for a target somehow bind what a future government is doing? If there would be no effect like this, governments would never care for their past target. Then there would be no relation to this at all. So this raises the question, what could be mechanisms that such a function S exists at all? And I think there also might, there's an uncertainty might play a role here, irreversible investments might play a role here. And I would suspect that some of those mechanisms might also work differently on the local level than on the national level. For example, if a local government can be held accountable at higher institutional levels, which is more difficult for a national one. Yeah, but that needs to be done. Yeah.
Maybe I can raise some questions that came to my mind. One is that the fact that if you have a switch in the local government from one political spectrum to another political spectrum, let's say from green to non-green, is it then reasonable to think about variable political costs? So maybe people change their mind if they recognize the costs of the interventions that they have created. And as it is the case now in Austria as well as in Germany, where you get the feeling that the green movement is put into defensive mode rather than that the political willingness of the electorate is still supporting green measures. Then a more technical question that I have, as far as I remember from agglomeration economics and economies, you have a very non-linear response of value added in highly densely populated cities rather than a flat density of the population. So this would call, I think, for some non-linear formulation of the S parameter in your model. And then did you have something like a low government budget restriction? So if you introduce new measures, for example, investment into public transport, you need more money. And where does the money come from in your model? Is it subtracted from alternative uses, or is it raised through additional taxes or debt? So I missed somehow the government budget restriction or the local government budget restriction. And then another point that always comes in these discussions is what happens with the existing capital stock. It's a huge amount usually. On the one hand, it's supporting, let's say, a public transport network, which is very dense, is supporting your climate measures. On the other hand, you run into stranded investments, and that's an additional cost. We will have some opportunities to show this in your model as well.
Okay, yeah, some very good points. So what is a good sequence? So we don't consider a public budget restriction here. So if the money comes from taxes or debt, that's open. But that could be an interesting entry point for unpacking these functions further. So thank you for this remark. The existing capital stock risk of stranded assets. So since so reduced form, they can be included in those costs, in those mitigation costs. So maybe you have a city when you have a lot of stranded assets, maybe then you have these cost functions is just steeper. But it could play a role if you want to unpack this function as the future political costs more. Right? If you have a firm or if you have firms that undertake investments today, taking a certain target for granted, and then those investments become sunk again, they might in the future lobby for sustaining the target, at least to some degree. That could be a mechanism. That's not in the model, but this is one possible thread to unpack that. Then the size and value creation. So in the economic costs and benefits, they scale with the size. And this is not assumed to be It's not completely non-linear, but there's a quadratic relationship that is admitted there. So this is maybe not perfectly represented, but it's partially in there. But you say that the size might also play out in the political costs, and there I'm not so sure how this might unfold. For the economic costs, sure. And then about switching preferences, right? This is, of course, we can say let's endogenize preferences depending on what is happening today. We might shift this in a way. Then, okay, then we get on shaky grounds. Maybe we need to make some further very courageous assumptions here. Of course, but there's a literature related to that. There's some literature on that comes more from urban sociology. That because we observe that these climate plans and targets and plans they are made in cities and not in rural areas. So that is also a question: why in cities, right? And what I've read from sociologists that say, okay, we have urban elites. These are people well educated in good positions, and they travel a lot. They know the other kind of people in other cities, like I'm here now from Berlin, right? And so this might be then these linkages might shift preferences in at least in cities more than in rural areas. But okay, that could be then we have a diffusion of certain preferences, maybe across certain travel gradients. But of course, there was a question about uncertainty, we might say, and that would be also again about unpacking these future political costs. So if we might have a certain probability that political preferences shift in one direction in the next years, and how does it then influence decision making today? Yeah, and then of course, if this uncertainty is high, I would expect that this X function would become rather shallow, and then the expectation would be that targets would be even less met if this political uncertainty or preference uncertainty is getting higher.
Or lower.
So you mean the targets get lower? Now you can then promise more because you're not punished anyway, right? If you can promise a lot because you say, okay, now I promise please my green people, but it's very likely that the brown will take over in 3 years and they will happy if I don't reach what I promised today. So that would be my intuition here. Yeah.
Okay. Anyway, is there a question still remaining? Stefan, you were raising your hand before.
Yeah. Thank you for your presentation. A very short question. It's about the role of the democratic power of the population. So, is it important that you have like strong democratic entities, or how does this plays in the model? If you have an entity that is non-democratic, what would change in the model?
Yeah, thanks. That's very important to clarify. So, since this political costs and benefits are so reduced form, it can also accommodate a non-democratic setting. Of course, then the shape of those functions will be different. But what matters for the target setting is that the local governments get some benefits when they make targets above or below a certain threshold. And this can be what voters in the city like. It can be a city which is strongly exposed to lobbyism, then this might be what their local industry likes and pushes the local government to do. It can also be a national government that requests a city to set a target. And if a city, like in the United Kingdom, and if cities then set no targets, they are actually they are punished by maybe by having a worse relation to the national governments if they don't do so. So this is then another external reason you might have, or they might be cut off from European Union funds. That's another one, and that also applies, of course, to the political costs. So from the general model, it doesn't matter whether it's a democracy or not. For unpacking it in detail and deriving the shape of those functions, and you want to have more quantitative predictions, it will matter a lot. Yeah.
Thank you.
Okay. Thank you, Klaus, for this interesting presentation.